Hello friends, today we are going to do hardness of the water. So hardness of the water is because of the presence of divalent cations, mainly magnesium, calcium, okay, and other trace metals also, but predominantly these divalent cations or double charged metal ions. Okay, so the hardness of the water is of two types: temporary hardness and the permanent hardness. Temporary hardness can be removed by boiling, and the permanent hardness cannot be removed by boiling. For that we need special procedures like ion exchange and other techniques also. Now now the hardness of the water is detected by some techniques. So one of them is the titration techniques, and the others also we can do by kits. Okay, so in titration, this titration is specifically termed as complexometric titration, where a known concentration of the chelating agent, or you can say compound forming agent like EDTA, which is called, it's a dye, an ionic dye, and this is known as, sorry, it's not the dye, it's called the titrating agent, EDTA. Okay, ethylene diamine tetraacetic acid. So this one is titrated, okay, to find out the the unknown concentration of the calcium and magnesium. So this EDTA forms a complex with the ions present in the water, and this EDTA is basically insoluble in water, so it forms a precipitate with these ions that is present in the water. The hardness is basically expressed in lot of units, okay, but the most commonly used units is milligrams per liter as calcium carbonate. So now for doing the hardness, we have three samples here. So these two are hard water samples and this is my tap water sample. Okay, so we would take 50 ml of the sample. The volume is totally dependent on the on us. So here we are taking one of the samples. So this is my hard water sample. So we should also check the pH. Okay, so pH is around 7. Now I am taking around 50 ml of the water sample. And here I am trying to find out the total hardness. We'll also find out the permanent as well as the temporary hardness. Now I'm going to add here now this is my ammonia buffer. The idea of adding the ammonia buffer to the water is to raise the pH so that it forms a complex or react with the dye. So this is my indicator here, and the titrant is 1 molar of the EDTA. Okay, now after adding the ammonia buffer, we will add the indicator, few drops. So now you can see the color has changed. Now we would, since you can see this is my DT titrate, and this my solution is already standardized using the calcium carbonate solution. Now you can see it's already zeroed. Okay, and also make sure it has no entrapping of the air bubbles. Again reset. Now I would add slowly and slowly till the color change. Now you can see the color has changed. So the amount of the EDTA consumed is 6.27. We would take around 100 ml of the water sample and then we will boil it so that the temporary hardness is removed, since we are finding earlier total hardness. Now I will boil it till it is half. Boiling, what we need to do is to filter it. Now we are filtering it. Now after filtration, what we need to do is again add ammonia buffer and a few drops of indicator. So you can see in few drops only the color has changed. It consumes around 3 ml, which is almost half of the the samples before boiling. So the hardness, okay, so total hardness in the first case it was 6.27 ml of the EDTA consumed. So the hardness expressed in terms of calcium carbonate per liter is equal to titrant volume into 1000 upon sample volume. So here the sample volume is 50. Similarly, the permanent hardness is equal to 2.99 into 1000 upon 50. Here you can see the total hardness is 125.4 and the permanent hardness is equal to 46.6. So if you find out the temporary hardness, which is equal to the total hardness minus of the permanent hardness. So this was all about the hardness of the water experiment that is done by titration in the lab. Next consecutive videos we'll talk about the determination of hardness using kits or using any kind of reagent.